Looking at this one, I'm going to use the elimination method. Fortunately, it's already in standard form. You can see the x's line up, the y's line up, and the constants line up on the other side of the equation. So all I need to do is I need to figure out, well, what do I need to multiply both, what do I need to multiply these equations by so that when I add them together, things cancel? Well, the least common multiple of 5 and 2 is 10. Least common multiple of 4 and 3 is 12. I could go either way. I made the coefficients on the previous example, the coefficients on the x's match on the previous example. So in this one, I'm going to make the coefficients on the y's match. It really doesn't matter though. So to make these into 12s, so the LCM 4 and 3 is 12. So I'm going to multiply the first equation by, let's see, I'll make this one into a positive 12, so I'm going to multiply through by 3. I'll make this one into a negative 12, which means I'll multiply the second equation by negative 4. Because that's going to make this into a positive 12 and that one into a negative 12. So when I do this, let's say I'm multiplying the first equation through by 3. So I get 15x plus 12y equals 30. The second equation, I'm going to multiply through by negative 4. So I get 8x minus 12y equals, I have to ask my calculator, negative 27 times negative 4 is 108. Now when I add these two equations together, I get 23x equals 138. And hopefully this comes out nicely. 138 divided by 23. Hey, looks like it does come out nicely. We got x equals 6. Now, suppose for a second that it didn't come out nicely. Suppose this came out as some weird fraction. That doesn't change the fact that this is the x-coordinate of my solution. And I kind of made a decision to cancel out the coefficients of my y's. Let's see if I can proceed without using this value. If I looked back at this at the beginning here again, I made a conscious decision to cancel out the coefficients for my y's. If I started over and I made the conscious decision to now cancel out my coefficient on my x's, well, the LCM, least common multiple, of 5 and 2 is 10. So let's see, if I multiply this by 2 and this one by 5, that's going to be a positive 10, this is going to be a negative 10. So that's what I'm going to do. I'm going to multiply the first equation by 2 and multiply the second equation by positive 5. So I get 10x plus 8y equals 20, negative 10x plus 15y equals, I have to ask my calculator again, 27 times 5 is negative 135. Now when I add these together, the x's cancel out. I get 23y equals negative 115. And negative 115 divided by 23 gives me negative 5. Just because I started over doesn't mean that the information that I found in the first part was any less valid, though. So for the first part, I found that x is 6. For the second part, I found that y is negative 5. So in total, I found the solution to this system must be the point 6, negative 5. This is a handy thing to do. Like I said, if you end up with a fractional coordinate for whatever you find first, if it ends up being a fraction, and you don't want to plug that into an equation and work with fractions, you can just do that first part again, but for the other variable. I am going to check my work here, though, just to be, I don't know what the word is, just to be safe, make sure everything works out. So for the first equation, you can see that evaluates out to 10 like I expected. For the second equation, negative 2 times 6 plus 3 times negative 5, I expect this to be negative 27, and it is. So I'm confident that that is the solution to the system of equations.